Do you remember when computers used to look like this? That was only 25 years ago or so. They don't look like that anymore, and because they don't, all kinds of new things are possible. And that's the subject we're going to talk about today with my guests, Fred D'Ignazio and Bruce Mitchell, who's an educational programmer. And we really ought to say more than two guests. We have a lot of guests here, and as you know, they give me the creeps a little bit. Computers scare me. I come from, I guess, the pre-computer generation, just slightly this side of the computer world. Fred, what has happened to allow this burgeoning of development?
Well, Ben, maybe I can reach over here now and ask you to show while I speak about it. But
I don't know if our camera can see that. Which camera we're going to
What Ben is holding
go
there
for here
is, and we've got a screen too. Perhaps we can show the magnified version. But computers have now reduced to a cornflake size or ladybug sized brain, and same goes for computer memory. And this miniaturization of electronic circuits has produced an ability to take, just like Alice in Wonderland, who shrank and entered a new world. Well, computers now, by shrinking down, can be installed in almost any appliance around our home, in our workplace, or wherever.
This is the computer chip. This is the latest generation of computer chip?
This new chip is about the most powerful thing going, and that single chip can duplicate the functions of the entire room-sized computer you were just showing.
Now, we've got a larger picture of the circuitry that's on this chip. Pull back and show, if you can, just how many intricacies there are on this tiny thing, which is a quarter of an inch by a quarter of an inch, something like that?
Right, that's right. What you have now is the ability, using something like an electron beam, to create a thin circuit that is so tiny that it's many times thinner than the width of a human hair.
Now, what does this development allow the industry to do? What's possible now with computers?
What we see, Ben, is a complete change in focus of the computer. Once in the past we had the computer as the reserve of large institutions, governments and corporations and so forth. Now we have the ability of the computer to go more places. It's so cheap that you can pack a lot of computer power in almost any appliance or device that you can imagine. And as a result, we're able, through new technologies, to create computers that have voices, computers with music, computers with colorful pictures. And then it's up to really the individual or the organization, the type of application they can dream up with any particular kind of computer.
There are computers that run devices that do actual physical movement and work. Robots, in fact, right?
That's right. We have what's called, in fact, the robot revolution. The 80s are called the decade of the robot. And we have, in fact, robots in factories, thousands and thousands of them here in the United States and in Japan and in Western Europe, that are taking over some of the tedious and dangerous jobs that used to be done by human beings.
The image of, for the older ones of us, Robbie the robot, and the younger ones, R2-D2, robots running around with twirling lights and flashing eyes, talking back to the boss. Is that what's going on in robotics now?
Well, again, you have this phenomenon where you can create and mold the type of shape of robot that you want. In industry, it's quite different. There, it's been described as like a fire hydrant with a giraffe neck and head hanging around. It's a single large robotic arm with a manipulator or a hand on the end that actually is used to weld, for example, parts of a car's body.
Now, those are actually in use right now, and I think that we have some pictures, some video that shows just what we're talking about in the factory.
Yes, right. What we have is showing today is a large, what's called Unimate robot that's being employed in this case to the robot arm you can see in the picture holding a welding gun. Here, another robot arm is picking up and using a machine part and from a vat of toxic liquid, and there you have another arm telescoping out to pick up a part. And you can see these are robots that are used in the automotive industry.
So robots can be used to handle the difficult and very dangerous jobs that men have to do right now.
It's ironic, in fact. Automation used to be seen as a bugaboo that, for example, organized labor might launch a counterattack to and oppose. But many members, for example, of the UAW are in favor of a certain degree of automation because the types of jobs that the robots are taking over are very undesirable jobs to start with.
What about application of robotics for the home computer? I mean, now we're getting into an age where you and I can go out and buy little computers. The early eds told us that we could use them to balance our checkbooks and to plan our meals and so on, but we're a lot further advanced now. We can do a lot more with home computers, can't we?
Right. What we have now, Ben, is a new ability to program the home computers using some of the new facilities. For example, if you have a computer that has a robot attached, then you can actually write a robot programming language. If you have a computer that plays music, then you can write, actually play on the score, play a score on the screen, so you can actually type in and put in the notes of the music that you want to have the computer play. So even programming has changed a good deal from the old idea where you just used words and letters and created complicated numerical functions.
So with a home computer, you can actually compose music, play it back?
Right.
Can you show us?
In fact, we have a computer here today. It's the Apple computer, basically, and a company in Raleigh, I call them the technological wizards, it's Microtechnology Unlimited, puts a tiny circuit board that you plug right in the back of the standard home computer Apple. And that board stores actual songs in this memory here, a floppy disk memory. And then when I press this button, then the tiny bits and bytes of electricity are going to be translated into musical notes on the speaker.
You're watching Sleepcore. Pleasant dreams.
これロボットですね。
ロボットの目なんですが、見てください。瞳孔、瞳が開いたり閉じたりしてるでしょ。
そうですね。人間みたいですね。どうしてでしょうか。
光を当てるとこんな風に反応するのは、中はこういう仕組みになっているんですが、実はこれはですね、患者ロボットって名前がついていて、救急車に乗っている方々が怪我をした人などの手当てをする時のその訓練用に作られたもの。例えばこれはこう叩くと目を開けるんですね。で呼吸をしたり脈拍を立てたり、あるいは心臓が動いたりという訓練用に作られたロボット、人間の暮らしに役立っているんですね。葛西です。
アンナです。
You're watching Sleepcore, media for insomnia.
Изображения внутренних органов человека получены с помощью аппаратуры для ультразвуковой медицинской диагностики. Заглянуть внутрь организма позволяет ультразвуковые колебания, которые излучает и воспринимает локационный датчик. Такие датчики, установленные на пальцах захватного устройства, излучают ультразвуковые волны в рабочую зону манипулятора. По характеристикам отраженных от предмета волн, манипулятор получает команды для самонаведения схвата на предмет. Руки чувствуют только инфракрасное излучение. Локационные сенсоры робота могут работать в более широком диапазоне. Этот радиоволновый локационный датчик позволяет измерять скорость и расстояние до движущихся предметов. Для сенсорной локации могут применяться также ионизирующие излучения от рентгеновских или радиоактивных источников. По мере приближения датчика к радиоактивному источнику нарастает интенсивность его излучения. Это позволяет судить о расстоянии до источника. Зрение дает человеку наиболее полное и точное представление об окружающем мире. Движение манипуляторов оператор контролирует собственным зрением. А здесь на помощь пришла промышленная телевизионная система, позволяющая увеличить расстояние между пультом управления и манипулятором. Теперь манипулятор может работать и на дне океана, и в далеком космосе. Но в любом случае для обработки зрительной информации используется человеческий мозг. Какие же при этом решаются технические задачи? Иначе говоря, какие функции должна выполнять система технического зрения робота? Исходная видеоинформация должна быть воспринята первичными преобразователями свет-сигнал. Их называют видеодатчиками технического зрения. У них может быть построчное сканирование изображения, или информация может считываться от отдельных точечных элементов фотоматрицы. Такие видеодатчики применяют для решения сравнительно простых задач технического зрения. Например, для определения положения и конфигурации окрашиваемых деталей, которые конвейер подает в рабочую зону окрасочного робота. В современной почтовой связи применяется более сложная система технического зрения. Она предназначена для автоматического чтения, или, как говорят, распознавания рукописных цифр индекса на почтовых конвертах. Когда индекс прочитан, письмо автоматически отправляется в соответствующий бункер сортировочной машины. В настоящее время разработаны более сложные алгоритмы распознавания разнообразных рисунков. Но плоские видеоизображения могут быть неоднозначно связаны с порождающими их объемными предметами. Поэтому алгоритмы распознавания предметов рабочей зоны робота еще более сложны. Очувствление в сочетании с мощным электронным мозгом. Таков путь создания роботов с элементами искусственного интеллекта. Кто знает, быть может, благодаря успехам биотехнологий, этих роботов будет не так-то просто отличить от многих из нас.